Okay, we're back. Let me just go get a drink. Just 1 sec, I'll just go get a drink. Alright. I'll just get started. So I think I stopped, how long ago? Was it like an hour and a half ago or something? I took a break and then I went back and looked at it. I'll give you the punchline. So basically, the thing we're stuck on is that these event records in the trace um, contain variable length data. And in this case, it's this type called a SID, a security identifier, which is variable length. And pretty much everything we could find online, including the official MSDN docs, suggested that, let's see here. I'll show you where I found out finally. Yeah, like there's this thing here which says it's a SID, and there's a bunch of other things we found online that suggest that that's what it is. But what it actually is apparently is a SID preceded by 2 pointers. And I wrote some other scaffolding kind of debugging code. One is I use this type, I can show that in a sec. I wrote this code that uses the TDH API, which is, I think it arrived in Vista, but basically it's something that lets you kind of, um, like, it's sort of a reflection system for ETW events, where even if you don't know the data you're dealing with, it will let you parse it in some generic way, so you can get the names of the properties and the types of the different fields, so you can write some sort of generic formatting code or processing code. We're not going to use that here because we're dealing with a known set of events, but it means that I could write some simple code here to basically get all the different property sizes, just to validate that at least, if I was seeing a given size, that it was sort of coherent with what the system thought. And so if we run that, did I? Oh, I had a token user left over. If you run that, I think you'll see. Oh, I guess I maybe removed that code. Okay, well, so we can talk about that in a bit. So these are the DC start events now with the proper image file name and the full command line. So that's all working. And you can see the code was extremely simple once we just got the offsets right. All right. Oh yeah, here's the thing I commented out. The print event properties, which uses the TDH reflection crap. So you can see the TDH code, or that I use, basically lets me print out all these sizes, and it correctly deduces the user SID data size. So anyway, I think I'm going to keep that around just because that was useful for debugging. Yeah, so I think, so this kind of gives us enough to, let's pop the stack. The reason we were doing this was because we want to be able to figure out what image names correspond to which processes when we see different events for profiling. So DC start and I believe DC as well. We'll probably bucket these together. We're basically going to have a Alright, so step one would be, we were using this get process name stuff before, and we already saw some of the issues when we used it originally, which is that you can basically with this you can run into the issue where a process that's dead by the time you're processing the trace, there's no PID for that anymore live, so you're not going to be able to resolve it to a name. So I think what we're going to do is well, I guess we can just leave that code for now, but we're going to use the same map, I think, since I'm just being lazy, I'm just using STL maps. So I think what we do is we just add an entry under the process ID, and we're going to do a stir dupe, which is kind of lazy. This is probably, no, it's not going to leak. We're going to free it. But yeah, we're going to do a stir dupe. I think we're going to do anything with the command line right now. But and then when things end, either this way or that way, we are going to free this thing, and then what is that? Is it okay? So I have to use an iterator. I'm just going to use C++14 crap or 11 crap because I'm right now. This is not the permanent way I'm going to process it. I just want to get some data managed so I can get a feel for the overall flow of the different events and how they populate the different data structures I'll need for actually organizing all this stack trace data I'm getting. So process names, find. I guess this is the second one. What did I do wrong? Oh, process ID. Oh, so what did I do wrong? Stir dupe. It wants me to use that one. What is it saying? Complaining about that. Initialization is skipped by. Okay. See if anyone of the old people came back. Alright. Just gonna keep trucking. So next step would be to go back to the code that you'd use get process name, and instead of using get process name, I'm just going to get process names directly. Now maybe I should sanity check this, although I think STL in debug mode will assert if I try. No, it will do that stupid thing where it'll give me a null pointer, so that will deref to null if I do that. But basically, this should be safe if I didn't fuck up, because the system guarantees that you're going to get DC start events for currently executing processes at event start, and then you're going to get start events for any subsequent executions during the trace. And so by the time I process the stack walk event, this should all be up to date. Like whatever is in the map represents the state of the process of the processes as of that moment. Not of the machine that I'm running this on, but of the state of the machine that was doing the profiling, basically. So let's see. So yeah, that actually worked from what I could. Well, there's some null pointers. So maybe I spoke too soon. I mean, this looks broadly correct. Like I'm looking at the different things. And like process IDs are, I guess, random enough that you're not going to get random hits that are kind of in the ballpark uh, by accident. Have streaming settings changed since? I don't think so. I don't think I've changed any settings. I guess you should be able to look at it on lower settings afterwards if once it's archived, if there's some weird buffering issues right now. But anyways, I kind of want to go and look at some of these nulls and correlate them to my. I had this xperf, the thing I put through at xperf. Actually, I haven't done that recently. I should redo that. Yeah, let me do that because then when I'm seeing these weird. So was this the very? It looks like it was like the second to last stack walk. So if I go to the end and do a Shift F3 for if I do this and then I do a stack backwards, so it's Shift F3. Okay. Shift F3. What are the timestamps? These timestamps look kind of crazy. I think maybe this one does the thing where with the timestamps where well, let's check these pointers. 881 E66. Yeah, so this is the same call stack. And this one, well, these look misassigned. And that's actually not true. The thing you're seeing over here is based on the image. So this just means that these things are on the stack. You know, function pointers or the return addresses were these. So there was a bunch of stuff on the stack from NTOS kernel. What about this? So maybe let's switch further back. This one is weird and truncated. I didn't see that with the. So this one is 2613. So that's this one. It's almost like this one here is not. Yeah, and you can also see there's thread 0 and all kinds of garbage. Oh, you know what? I'm not checking the event type. That's it. Yep, I'm just being an idiot. I'd forgotten that, I mean, this provider has more than one event. So that must just be it. Okay. Nope, that didn't actually fix it. So it's indeed, or at least it thinks it's that. Well, let me actually, I think the easiest way is just to pull this out and then assert that it's just do it here, so that should catch one of these instances. Maybe there's a field I'm supposed to be checking. Okay. So what is the process at this point? Header size is 16. This is 1. 24 to 16. And like thread ID is 0. There's all this stuff. How's this seemingly? Well, maybe this means kernel. Which I guess would also explain why. Maybe I'll just do it that way. I don't know if this is actually correct, but just do that, even though that's a total assumption on my part. But given that there's like it wasn't able to do anything with the stack, it's process ID 0. Well, actually, I can just search that. Like, the thing is, I thought 0 meant maybe like, you know, just like the thing was never filled in, or it was just the default value. But Windows process ID 0. Oh, okay, idle. Maybe I should do it up here. You know what? I should just do it like that. I should just fill it in here. Didn't I fill that in? I wonder why that would not work. So I filled in this entry. It's probably because assuming it's because of that. I see, so that's definitely a valid process ID. Just doesn't have anything in there. Actually, let me just try to find that again. I'll go and look for it in the text. What was that? That was 4188. Explore XE. So there's a PDC start. What about PDC end? So all the DC ends are okay. Maybe I should not. Let me just try this. I think maybe that's what's happening. Yep. So it looks like, in case that wasn't clear, it looks, what I noticed is that there were actually call stacks down here that occurred after the corresponding PDC ends. I actually don't know why we keep getting stack events. It seems like basically once the system has this, so the DC end events come in, I think, when you're supposed to be shutting down the system. So, or like it's trying to shut down the session, the data collection session. I'm pretty sure the DC events are for that. Like, if, for example, if you look, I believe when you look like in the middle of the capture, you're never, like, if I search for DC end for here, oops, DC end, you can see it jumps to the end. So it's sort of like after it's decided to, if you will, turn off the faucet or to stop collecting data, there's an interval where it's kind of getting all these events, but it's also still getting stack events. And some of those stack events refer to things that have these DC end events. I see. So maybe DC end should only be interpreted as we're no longer collecting data for this specific process or thread, but you can apparently still. Okay, that's a little bit counterintuitive. It's not quite how I expected those events to work, but it shouldn't be too difficult to work with here. And we shouldn't need to do this hack because I think we should get a DC start for idle. Yep. Okay. So that was all it was. It was because those DC end ones were removing the entries in the map. All right. So for now, we're really only mapping this to names. I think the next step probably is to get image load events. So image load events let us figure out what DLLs and other things like that. Well, it's DLLs, XEs and DLLs that are loaded in a given process, and what the load address is. And from that, we can basically figure out. Well, we can basically load the. We can use debug help to try to resolve the instruction pointers to try to get some kind of meaningful symbol data about from all this call stack stuff. So let me see if I can find some image events here. All right, MSDN image. Image load. ECW event image load. Nope. Okay. Image. Alright, so we now have to add stuff for this event. So why is it sampled stack walk? That's crazy. I can't believe I somehow Oh no, that's right actually. No, it's not. What the fuck? Mm-hmm. Alright. So now we need a bunch of events for event image load. And there's load. There is event image unload, which is type 2. DC start, which is 3, and then I think I'm just going to call it DC load. Because it's all the same stuff, so this is 3. Is it really 10, not 1? So it's like 10, 2, 3, 4, even though this is a natural progression? That's a little, well, I guess we'll see. Yep, looks like it. Okay, so neat n of instruct. So this is image base. It's a pointer. Image size is a pointer. This is size t. Process ID. It's 32. Image checksum, presumably also fixed. Default base. Process ID was it? Default base and then a pointer. That makes me wonder if there's going to be some alignment funkiness, because default base, I wonder if reserved 0 is just padding. I guess we'll find out. So the thing I'm noticing, so on 64-bit, this is 8, 8, 4, 4, 4. Right, so this, what was it? 8, 8, 4, 4, 4, 4. And then this is a pointer. And so if you want this to be 8-byte aligned, like, so maybe this is to 8-byte align it, just in case, but that, so maybe I should actually do that. One, two, three, four. And then I think well, is file name ASCII? Nope, it's not. Okay. should pull this out a long time ago. Type is the 16. And we had, what was it? Event image. Now we're just gonna output the file name, which this time, since it's the only variable length piece of data in the structure, we won't have to go through, hopefully, any of these contortions from last time. So the question of whether this works or not is really a question of whether I got my hunch right with the reserved zero padding thing. Entirely possible I'm way off. So let's see here. Nope, I was totally on. So that reserved zero really was padding. I should add a comment because if I want to make this work later, so we got all the image load events. So right now they are, we're just putting the file names. I would say the next thing we need to do is that we have this process names thing. I think what we need to start doing, I'll just remove this because that's totally out of the way. I'm actually also going to at least put this out of the way because it's starting to interfere. So I'll put it up here sort of with the generic debug junk. Like this is the utility section. This is the trace recording. Actually, I should, yeah, event provider goods. And at least one of these needs to be higher up because it's used, the perf info GUID is used for the trace recording. Profile recording. Profile processing. Alright, complete this one now. Okay, yeah, so do I actually use this at length? I think I should be able to, was it length get SID? No, it was get length SID. I think it was a built-in. Let's just verify that that doesn't break anything. Yeah, that still gets the process name. Okay, so let's just get rid of that macro. But yeah, I think we need something like process info, and I guess we can keep the image file name in here. And the other thing I want to put in here, well, let's see. We also need like image info. What did I put in image info here? Like, I mean, in theory, I actually could just do a copy of this crap. So literally, it would be nice to have these file names out of line, because when you're actually putting these, for example, in containers, it makes it awkward to have variable length structures. I guess you could make an argument against that. I am doing a lot of copying now, so maybe I'll just bite the bullet and revisit it later. So yeah, we need the image file name. We need command line. And so we also need to convert to ASCII, because the command line is stored natively as UTF-16. And we need to store a list of loaded images. I assume that images are, like, the events themselves are per process. I'm trying to think of how nasty I want to be with STL stuff, just to move ahead. Okay, probably what I'll do is I'll use a linked list. You know what? I'm just going to have a fixed size array and make it real big. So let's say there can be at most, what's a reasonable number? 256. We'll do bounds checking on it, or we'll make sure we check it. I think we don't need that then. So the image needs okay, let's just do this. So the image, there's an image base. Image size. So this gives us the range. So between so for you guys who haven't maybe thought about this stuff before, you know, when you load a DLL into a process, the section of code is sort of coherently loaded relative to each other, but it can be offset as a whole, and that's what the image base is. And so, effectively, if you take in a given instruction pointer in the process, and you compare it to these intervals, you can find out what image a given pointer belongs to, just by going through all the images of a given process and seeing which interval it falls into. So that's actually kind of a good first thing we can do with all these different instruction pointers, is we can try to classify it against the actively loaded images in the process the sample was taken from. So image info, we're not going to store the process because we're always going to have that in the context. We don't care about image checksum or timestamp. Default base is actually required, I think, because the pointers, I think the PDB data will be relative to the default base, which is the default load address. That's where it prefers to be loaded. The image base is where it was actually loaded. So for example, if you're loaded at default base, you don't have to do any relocation. If you're loaded at something else, you have to do relocation. The difference between these two will then be the offset. You have to kind of reinterpret the PDB data based on, I guess. I can't remember how much of this debug help DLL actually does for you when you use that. But anyway, let's put this in for now. I guess I need vector. All right. I should actually put in the was it image info. I should put in the file name. And I'll do it in ASCII. I don't want to have non-ASCII. Honestly, I'm going to do UTF-8 even if I want to eventually handle other stuff, and then I'll convert at the boundaries to the Windows API to UTF-16. That's usually how I do stuff with Unicode if I'm trying to be serious. Okay, so we have an image load event. Okay, yeah, right. So we had process names, and this is going to start becoming this. I'll just call this processes. So rather than process names, we're now going to get a process info. And we're going to assert on this, and in this case it's really not optional. And then we're saying not process file name, I think just process name. Is it image file name? Yeah, image file name. So that's that case. And what was the other one? Oh, right here. So rather than doing this, we're going to, so I have to call it process info here. We're just going to we're going to allocate this thing image file name. We're going to have to duplicate that because this thing lives in line. And then what was the other stuff we had? Actually, I guess I can't. If I want, do I really have to use new? Okay. This will really have to be temporary. No, fuck it, I'm not using vector. Command line, let's store that for now. Image count and images. Okay, that is essential. So we create this, process info, I already did that one. For the second one, I need image count to be 0. I assume I get the DC start before the corresponding image load, but I should definitely verify that. I think that'll happen automatically. We'll assert on that when we do the image load handling. So okay, so this is good. Then we have to, in this one, we have to find this using parent, what is it? Process ID. And this will effectively ensure that that we don't get these out of order, because if these happen out of order, then this process won't have been created, and this thing will give a null pointer. Alright, so in this case, I guess we need to do a string conversion, wide char to multi-byte. This will be ANSI code page, the multi-byte string. What's the thing I'm converting? Oh, it's the file name. I guess we can use max path. Yeah, let's use max path. This does make the overhead for each of these process infos incredibly large. Yeah, let's do it. Why not? So this is max path. God, reading this garbage and the autocomplete. Code page flags, wide char, number of wide characters. Okay, so this is flags, wide char, so that's this one. And I guess we need to do this. It won't figure that out for itself. Well, I should go read the docs. Can't remember this shit. Let's see. ANSI code page. Oh, that's right. I think it's just 0, and then if the string is non-terminated, it can be set to. Okay, so -1 for null terminated. I should remember that. Pointer to the buffer. That's file. Wait, what was process info here? Image file is already converted, so why am I converting that? This is for the image load, right? Okay. Image load file name. Okay, so image count plus. Well, images, image count, file name. Max path. 0, 0. I should do that through this, just to make sure that I did the conversion in some halfway reasonable way. Okay, what did I screw up? I should also do the association. Process names. Okay, so now we don't have this. Now we have to, I guess we have to free this one. Then we have to free the process info itself. Okay, it should be like that. I should brace because C is stupid. Alright. let's try that. See what crashes, if anything. Okay. Looks like this thing is actually longer than max path. So I think maybe the max path idea was just me being trying to be file name size. Let's see, so that was image load. Okay, that worked. By the way, like, I'm writing a lot of code in line that I'm going to pull out soon. Like, if you guys think this is crazy. But when you're just writing code, at least I find that until it becomes like actual friction, I like just keeping up momentum by just keeping things in line rather than constantly kind of getting context switched by trying to refactor things into nice pieces. It's also easier to do that once you actually have some distance. If you make those decisions in the moment, you sometimes miss better opportunities that become available later. Anyway, okay, so we have that. I think we had other fields we wanted to fill in. So image load, default base, image load, image base. Apparently I can't spell. So this is the initialization. So I'm not done yet though, am I? No, I guess I sort of am. Actually, the thing I should definitely assert is that image count less than max images. Let's see, so that means that now, in theory, oh, we have to do unload as well. So to do unload, I guess we're just going to do an m-squared search. And I guess we can do that on image base. Okay, so when we step 1, finding the process. Make sure we actually have one, that we didn't get some weirdness there. Step 2. Well, I guess we should definitely make sure we have this. More than one, otherwise something went wrong as well. And then we want to this is not, you could imagine doing this in faster ways, I guess, but since everything's stored as an array, this is, I think, convenient. You basically check whether we want to check if any of the image bases match. I don't think there's any other, they have to, if they match, they're definitely the same image. So we don't have to do like a string comparison is what I'm saying, which might be the more superficially correct thing or more expedient thing, but this seems to be the better and more robust way maybe. So yeah, we have to compare this to image load, image base. And if we found that, then we need to finish. And having finished, actually, I'm going to pull this out so we can do an assert. We're going to assert that this is not equal to the image count. And then we're going to decrement the image count. So in this case, we have to free the image's file name. We don't have to free the image structure because that is owned by the process info. What's this? Process images. Equality has. Did you intend? Oh. See, that crashes. It did crash. So there are actually more than 256 images. Let's try cranking it up to 512 and seeing when the pressure point, or if that's enough. You know what? I never decrement image count. No, I do. Well, you know what? Let me look what processes are actually causing these issues. So there would be currently 250 or 512 of these. This is dep env. Holy fuck. Okay, I guess some things just have a lot of frickin' DLLs loaded. Okay, so this was a case where the thing we're searching for was not found in the corresponding process. Why is that? And what process is this? This is a Wacom tablet process. Well, so this suggests that am I not doing, definitely, so let's see here. Is there anything that can happen up here to make this not occur? I'm doing it both on load and DC load. So 61 images loaded, and apparently none of them match. You know what, for a sec, let me just see how many processes that occurs with by turning this into just check, and then I'll print a diagnostic. Okay, so that one failed too. So it only happens near the end. let me just try that out. I want to repeat, but I'm pretty sure that only happened near the end. No. Well, I guess that's sort of near the end. Not really. Okay, so what about this logic is potentially not valid? Could it be process ID reuse? Well, actually, let me go and look at them over here. Oh, so there's no load. What are they called then? That's pretty interesting. It doesn't seem like there's any load events, really. I could somehow understand if this was for DC unload, given some of the weirdness we'd seen before, but this is not that. Let me clear this and then do a run, and then I'll copy this into a text file just so we can search it more cleanly. I want to see when those actually, you know what, so rather than saying image unload failed, I should do that, and then make sure on image load I also print the, actually, yeah, I should just use the P and then image base. Yeah, I do assign that. Default base, image size. Actually, let me clear it and then make sure so we get it all. Okay. So image load. So there's a bunch of these, and we get all the base addresses, and they look in that range where code lives. Okay, let's look at unload. So first off, there's not a lot of unloads, period. Which means that, like, the fact that a few unloads are successful doesn't mean much, because I actually think the majority are unsuccessful. So let's see here. Image unload. Why is there no parenthetical thing? Oh yeah, unload failed. So here we have this thing. Is that not loaded, is the question. Image load, we should make sure there is also a process ID for these things, because that could be part of the mix-up. switch unload, and then we have process ID. So that's for process 1644. If I look at this load event, God, didn't I put that in parentheses? Nope. I did not, because I'm an idiot. Okay, so 1644. Yeah, there is actually no... That's weird. I never got a load event for process 1644. Let's see, 1644. I do have a bunch of other ones. That's fairly concerning. Let me just see again here. What's the name of this? Was it? That's interesting. It's almost like the image unload event for the main executable. In other words, not the DLLs, but the main executable is part of that issue. No, that doesn't really make sense here. So I go and look at, dev env. There's none of those events. I wonder if I missed events. I'm trying to remember event record, or even, what's that thing called? I think the overall trace will give you data on whether you missed events. Missed event record. Maybe this one specifically. Yeah, probably not this actually. Like process close. I believe this one fills in the log, so I should check that. I think this one gets filled in after you call open trace with some data about whether you missed events. Events lost. so there's no events lost. That's reassuring, I guess. But it doesn't get us any closer to understanding why we have these unpaired image load events, or unload events rather. Okay. Let's just think. Could there be... I don't think I handle event 4. No, wait. 10, 2, 3, 4. I don't handle the... Well, we can try doing that. I'm worried the same thing will happen that happened with DC end on processes. I mean, this will make the problem worse, not better, if anything. Yeah, you can see it's trying to unload all this stuff that's no longer there. Okay, that's concerning. There is no if check or anything that could cause it to miss this. Are there other providers, I wonder? Because I see often they have like different versions of a given event, like image 1, image 2. Is it because I'm not checking the version? That's a really interesting. I hadn't thought of that. But there's not just type version to worry about. Let me print that. So the version is from the header. Actually, I should clear that and rerun, so I got a clean thing. So this is version 2. Let's see what things we actually get from this. Wait, didn't I print that? Oh. Getting tired. Okay, version 2. Seems like a lot of this stuff is version 2, which is this top level thing. So probably I should assert that it's version 2. I should also put this up in a type level variable. What type is this? It's also UA. Okay, so it's not that at least. That's encouraging. I need to make a note to myself and move on, otherwise I'm going to rat hole too deeply on this. I'm going to leave this here just as a reminder to re-enable it once I get to the bottom. Alright, let's say that's good enough for now. The other thing I haven't done is, I did clean this up, so that's good. So to rehash, we should now be able to, given an instruction pointer, okay, so that's fun. I also have to go to bed soon. It's almost 1 a.m. in Seattle. I think the final thing we're going to write, given the stuff we've written, is we're going to write a function which finds the image corresponding to a pointer and prints the corresponding, or returns the name of that, or returns the image from which you can print the name. Find image for instruction pointer. So you pass in a process, an instruction pointer, and honestly, couldn't be easier the way we set things up now. We check if the, well, let's do it like this first. We check if image base is sandwiches, the thing, and if it does, then we return the image. Otherwise, we return 0. And I think for now we will assert, because we don't want to actually call that unknown size. Oh, because it's, yeah, we can't do that. We can do this though. All right. Get image. So now, if we return at long last to our stack tracing code, and by the way, I'm just going to mute this spam for now. I guess the piece de resistance now is to do something with these stack walk events. So we have a process, and we have an instruction pointer. and we should be able to find an image. And from that image, we should be able to and then print the, so first we just print the instruction pointer and then we print the image file name. I just renamed this. Okay, does not work apparently. Let's see. Well, actually, let's do this for a sec, and then I just want to see, before I get too deep into an investigation, I want to see if it's like 90% resolve and it's just some weird outlier. And why do I use printf again and again? So CCC doesn't have anything that resolves. Let me just put this into another file so we can see more easily. So this actually looks right. And given that 64-bit address space is pretty damn large, you're not gonna. I mean, and like, I mean, and this actually looks great, right? Like, think about what this is saying. This is saying that the process was started in NTDLL, went through this user space kernel thing, went into my main function, did some stuff, eventually called out to user. So this is like doing some painting and LPK, I don't know. But anyway, so like this call stack looks, I mean, this is what I would expect to see basically. And then some of them are unknown. I wonder if yeah, this actually looks, it could be the unknown is for like a background thread. It is kind of weird though that, well, actually I want to see what these are, because if you go to the temp, yeah, so these are in win32k.sys. That is not something I've seen anywhere in any of my image load events. That is very interesting. I wonder if it handles it specially somehow. Oh, actually, the reason I couldn't do that search to look for the Win2Ksys is because I removed all those image load events. I'm going to put those back just for some testing here. Yeah, there's no W2K or whatever that thing was we saw over here. A lot of other stuff, but there's none of that. Or sorry, it was Win2K. Was it Win32K? .sys. Okay, let me just, I think I compromise it. Win32K. Okay, we do have that. It really does. So like, so let me see what that looks like. Right, so you can see here where the corresponding call stack over there had this Win32K sys. I do have a Win32K sys, but it was only... I wonder if it's because this is always loaded. This is like the thing that's always loaded. Yeah, that must be what it is. So this is like a special... This is like a implicit image load almost, maybe. Because we only saw it... like, the only reference to it is here. So maybe I just need to fake it. Okay, so I'm going to do something nasty here. What I'm going to say is if our process ID is equal to 0 and image base is equal to this, then debug break. I guess this has to be like ULL. Okay. So image base is this. Image sizes. Okay, so let's Win32K sys. So what is that thing called? Win32K sys image. So I'm gonna make a hack here, and for all I know, this is actually what xperf does. And then anytime there is a process creation, this is super weird. Well, process ID is not 0. Then image count is actually 2, and the first one is the only reason this could possibly be a semi-reasonable, by the way, the hack I'm doing, is that I'm going to assume that this is something, since it seems to be some kernel stuff, this basically represents the kernel, and it's always going to be loaded at the same address in all the different spaces, and so I should just be able to grab the same pointer data and replicate it over everywhere else. Okay, that definitely doesn't work. I think probably this is too early. I think the DC starts happen before the loads. So I need to do something like this, like, let's see here, processes and image count. Give me this down here as well. Process info in an image count 0. Does that work? Process ID is not. Oh, I guess it was part of that context though. Image load. Really, this pushes it over the edge? Oh, I see. It's because it does it for every single image, so it redundantly loads it. So I want to have two conditions. If this is 0, also how early was this thing loaded? Yeah, so that's fine. So if we loaded no images and the process ID is not this weird idle process, and then we do this. Okay, that did not actually resolve that issue. Instead, we now have some really dubious, I think because they got free out of order. Let's see what the first unknown is. It looks like it's all these sys files that are just, like, we get notifications for okay, so maybe I should just think about this differently. I think I should essentially copy maybe all the sys. Yeah, it looks like image load 0 is, oh, I see. So, okay, this makes perfect sense. Now I'm on board. So I'm actually sort of on the right track. Remember before that process ID 0 actually represents the idle process. So in no way does this actually represent a real image load event. This is just a way of saying this is the universal set of images, and they don't want to repeat them from every single process because it's really repetitive. So actually, rather than doing this, what I should be doing is basically assert let's see here. Process 0. Actually, so first off, let's move this inside. So yeah, I think the first order check is to make sure we're not dealing with a pseudo process. And then once we've done that, we can say actually, we can get this process 0, and then we should assert that current process image count plus the ones we're about to jam in here, let's see, -1 is less than max images. And then at that point, we should do a memcopy from process 0 images, process 0 image count times size of image info. Okay, so make it bigger, faster, stronger, slower in this case. Must make it even bigger. Oh, right. The thing I still haven't done is I only want to, okay, so maybe that was the problem. You only want to do this the first time you do an image load. So this is like a preload kind of thing. Did not do a fucking thing, so not sure if it... What, if anything, did I do wrong here? Process 0. Actually, a good litmus test for me is to set a breakpoint like here, and just take a look at what has been copied in to make sure these things actually made it in. Oh, this never hit. Interesting. Wait, how can this not be hit? If the process ID is non-zero and the image count is 0, that I do not understand. So, image count 1. Did I do something stupid with the... Oh my god, are you kidding me? Did I really do that? Okay. Yes, I don't see any unknowns, but I do see some fucked up. Well, I think that's is unrelated actually. So let me. I think I know what that is. That is the weird unload garbage. So because of that, I'm going to temporarily remove that and rerun. Because I think I saw no unknowns yet. Yep, perfect. Ship it. So yeah, this is another one of those cases where if you process the events in the order they occur, you can't like free stuff up. So I don't really understand what the intended ordering for the processing is here. Okay. All right, I think that's a good point to stop. Honestly, after running into that stupid bug with the SID size not being as was documented, I'm happy I got kind of back on the horse and tunneled through it. And now I actually made some good progress. This is a good first step. The next step after this is to actually start symbolizing. So because right now we have all the call stack data and we know what processes everything belongs to. What we don't have is the ability to bucket these instruction pointers by some useful unit, like typically functions, right? That's what people do. Once you have that, you can then start bucketing on those things and building, building buckets for like, oh, this function is executing 90% of the time or whatever. Right now, if you try to do that on instruction pointers, it's not going to be useful because you can have, like you can have instruction pointers that are close and in the same function but still distinct, and so you really need that symbol resolution in order to do useful bucketing. But anyway, so that's the next step. I will probably do that tomorrow night and over the weekend. So anyway, hope people got we're pretty happy with where we ended up. I'm actually fairly happy with this. It's a good amount of work. So see you guys. Where is OBS?